Right, welcome to grade 12 functions, inverse exponential and logarithms, and I think it's time to make it maths. So, welcome to all those special people out there, and let's have a quiz. Our first question is, what is a function? Okay, so function, you might think, okay, we got some input and a rule that gets it to an output. That's a relationship, and we're going to see what makes a function such a special relationship. Okay, so let's draw a couple of relationships and see why one would be considered a function and the other not. So yep, grab this down, of course, pause if you need. Okay, so I'm going to draw a line and it goes like this. And I'm drawing a function and it's going to go, let's take it down as well. So there it is, carries on that way. Maybe it stops over here. And I say that this is a function and we're not going to really spend too much time here, but to go, can we draw a vertical line? And that vertical line only crosses the relationship, the graph, only once. So here, wherever you draw a vertical line, it crosses at most once. So you might draw it here and it doesn't cross at all. That's fine, as long as it doesn't cross it twice. So this is a function. Yay, hello function. We can draw a vertical line. More rigorously, we're choosing an X input and we see that there's only one Y output. But vertical line, vertical line. Okay, so let's draw another one. And this relationship I'm going to draw is not a function. And let's see what's going to make it not a function. And I'm going to draw it like that. Maybe it carries on that way. Maybe it stops and excludes that point. Doesn't matter. The point is, can we draw a vertical line and it only crosses this once? Well, here we can, sure. Here we can draw it and it doesn't cross at all. So you feel like, hey, maybe it's a function. But all it takes is one place where we can draw a vertical line. It crosses the relationship more than once, therefore not a function. For this X input, there are two Y outputs. So for this one, not a function. Sorry for you. Okay, so visually what we've said is vertical line test. Can you draw a vertical line or not? So let's have a look there, and I'm just going to come back with some examples. Didn't notice that jump cut at all. Okay, so I'm saying let's spend some time. We've got 7 examples here, so get comfy, get ready to jot down a few examples. Hey, if it takes us 5 per example, half an hour, well spent. Okay, so we've f of x equals 3x minus 12. What type of function is this? Well, maybe if we wrote it in this form, it would just feel a little bit more familiar. Y equals 3x minus 12. That's how we started these. These were straight lines. If you remember, this bit here was m, was the gradient, and this negative 12 here helped us get the y-intercept, something like that, 0 minus 12. So we maybe had a sense. So let's have this over here, x and y. And what do we need to do? We need to draw this graph here. So we know a few things. We know the y-intercept. Good to pop that down. So minus 12 is going to go, let's put it right here, right over there. And I think it's good to put this 0 minus 12. So behind my head, we can actually put it there. Okay, and then we know that it's a positive gradient. So we can almost think already that it's going to go in that kind of shape. But whether we draw that or not yet, the point is we know we're expecting an x-intercept right about over there. That's it, there. Okay, so how do we find the x-intercept of any function? Well, we just substitute in, right? So we know something about that point. So this point, we know that the y value is 0. I'm spending time on this straight line because what I'm going to do is reinforce the same ideas for each of our functions we draw. What do we know about that point? What can we find out? What do we know the straight line's a positive gradient, etc. So we've got a 0 there, so we can go our y value is 0 equals 3, our x value we don't know, minus 12. So we rearrange and manipulate and go, okay, plus 12 each side of our equation. 12 equals 3x. Divide each side then by 3, and we get x equals 4. Or perhaps you saw that 3 times 4 minus 12. So we get 4, and we've got everything we want. Let's really just nail down one more thing and say, let's say that for our y-intercept, we didn't remember that we could read this off. Then for our y-intercept, we know y equals 3. We would have known our x value is 0. So 3, 0 minus 12 gives us minus 12. Okay, so last bit that I'm just reinforcing for this bit is here our input was 0, our output was minus 12. So we've got that as a coordinate. Over here on this one here, it would have been nice if we had also just finished off and gone, oh, so when we input 4, we got 0 out. We're just finishing off with full coordinates. It means all this working out got us to 4, 0. All of this working out here got us to 0 minus 12. So again, as I said, just kind of overthinking the straight line, because these concepts we can take forward to all our other functions. Good to go? Cool. Example 2. G of x equals x squared. What type of function is this? And then, of course, is it a happy or sad parabola? Okay, it's a happy one, right? So this is kind of our most basic parabola in some ways. So we go, oh, okay, we know that on our x and y axes, we've got this function, and we probably just already have a sense to go, okay, it is a happy parabola that goes up like that. It goes through this point 0, 0. If we weren't convinced, okay, well, again, let's maybe think of this as y equals x squared. And so if we substitute 0 in, let's show it actually in this way. So if we substitute 0 as our x value, we get 0 squared, we get 0. In other words, when we input 0, we get 0 as an output. Okay, so just getting used to that. We have looking at functions again, 0, 0. I think good to go on that one. Okay, let's translate our parabola. And what does this kind of negative 16 do to the parabola? Well, what it does to the parabola we had before is that the negative 16 just moves it down by 16, or translates it vertically. So now when we've got our parabola, it's good to have a bit of a visual image of what our parabola is going to look like. So again, if you drew it yet or not, the point is we know that our basic parabola was here somewhere, and this one here looks a little bit more like that. So what's useful here is that we know that there's going to be this y-intercept. We know that x is 0. We know that there are two x-intercepts where the y value is 0. Yeah, our x value is 0. So we already have quite a sense of what our graph's going to look like. Now I'm going to go the long-winded way here and go, okay, to find out our x-intercept. So let's maybe write here our x-intercept. We're going to go f of 0, because we know x is 0, equals 0 squared minus 16 equals minus 16. So 0 minus 16 is a point in our function. There it is. Okay, and then for our x-intercepts, what do we know about our x-intercepts and how are we going to find them? Well, we know that the y value is 0. So let's throw it in here and go, okay, so for our, whoopsie, I did this the wrong way around, hey? This just rewind. That was the y-intercept, right? You know, like, oh, okay, so we're back. And for this one, this was our y-intercept. This one here is our x-intercept. And so for our x-intercepts, and we already know that they're going to be 2, because we have a good sense of what our picture looks like. So here we're saying that our y value is 0, and we need to find these two values. Now there's half a chance that by this stage you said, okay, well I know it's minus 4 and 4, but let's go through it thoroughly and say, well, if we're given a quadratic, generally our strategy is make sure we got equals 0 one side, factorize the other, and we got x plus 4, x minus 4, so x equals minus 4, or x equals positive 4. That would be maybe a nice way to solve this. So what we've worked out by doing that is that negative 4, 0, and 4, 0 are points, and there they sit there on our x-axis, negative 4. Really winning today, aren't I? Okay, so there are 2 points, and our function's pretty much drawn then. We've got everything. Okay, we've got all the x-intercepts. Okay. So again, just really reinforcing all the steps that we're doing, even if you would have wanted to just draw the function, put the points in, and be done. Let's see one. Okay, 4th example. What type of function is this? It's a parabola, right? Now, what form has it been given in for us? Well, what form? It almost felt like what I'm asking there. Well, it looks like it's in turning point form. So from this, we already know what the turning point of this function is. So what is the turning point of this function? Well, remember, this was like x minus p squared plus q. So p was this value here, so it's a positive 3, and q is minus 1. So in other words, it is translated horizontally, it's moved right by 3, and vertically it's moved down by 1. So now if we look at this and we've got our function ready to go, so on our axes we go, okay, we know our turning point is 3 minus 1, so let's put it about there. Now it's not clear yet where the x and y intercepts are. Does it go through like there, or and the turning point is just over here? Okay, so we don't know exactly where it's going to go. Just a second, was this a happy or sad parabola? The happy parabola. So already we have a sense that, it's going to go like this, but we don't know yet where. We don't know if it's going to go through an x-intercept there, through the origin, or there. We don't know if the y-intercept's there, or if it's there. So I recommend let's find our y-intercept, because then we have a sense of where this graph goes. How do we find the y-intercept of any function again? Well, we know that x is 0. So at this point, wherever it is, x is 0. So for our y-intercept, let's get this right this time, intercept, we know that x is 0, so we're going to find g of 0 is 0 minus 3 squared minus 1. 3 squared 9, 9 minus 1, 8, right? So we've got 0, 8 is a point on our graph, on our function. So that's going to be up here somewhere, right? So 0, 8. Now we already have a sense of what this graph's going to look like. To go through those points and to be a happy parabola is going to look exactly like that. I could be a computer program. I draw these so accurately, right? And that point there, we kind of squish to make a bit bigger like that. Okay, but there's what our graph looks like. And now what we know is that, these two x-intercepts are both going to be positive. So we're going to find that. How do we find the x-intercepts of any function? Well, we know the y value is 0. So in this case, if we draw these, we know that that's 0 and that's 0. I'm a big fan of writing information as we get it. So let's do that. Let's find our x-intercepts. We know that there are 2 of them. I want to go through this in a method you may have done differently. Maybe it will help save a bit of time. So we know that we said our y value is 0 equals x minus 3 squared minus 1. So one option is to multiply this all out. Option 2, it's plus 1 to each side. So we've got 1 equals x minus 3 squared. We know that this part squared must be 1, because then 1 minus 1 gives us our 0. So what when we square it gives us 1? Well, we're taking the square root. So we're going the square root of 1 is 1 equals, I need the brackets here, x minus 3. Or we could take the negative square root. This bit in the brackets over here, just over here, could be -1. So -1 equals x minus 3. And this feels a whole lot simpler than having multiplied these out and gone x squared minus 6x plus 9 minus 1 and then factorized. So it is quite a useful way to look at it. Okay, let me move over here. So I want to keep everything on one page. So from this one here, maybe I'll just scroll down. From this one here, we've got plus 3 at least on each side. So x equals 4. And on this side here, we're going to plus 3 on each side, so x equals 2. So what we worked out is that 4, 0, and 2, 0 are points in our graph, which relate to these points here, 2 and 4. And as a last bit to look through our parabola, notice how we've got the turning point here at 3, 1, 3 minus 1, and our x-intercepts are equally spaced on each side. So we've gone 1 each direction. Just a handy thing for parabolas. Okay, onwards, upwards, 3 more examples, but I think valuable time spent here. Okay, what type of function are we given over here? Well, we're given a parabola. In which form has it been given to us? Well, it's been given to us in turning point form. But it almost feels like, wait a second, but then it's always x minus something squared plus something. So maybe it's worthwhile just adding in, maybe I shouldn't do it in yellow, let's do it another one, plus 0. Then it's quite clear, or at least a little bit clearer. So our turning point now, we can see, well, we subtracted 2 and we've added 0 at them. So there's our turning point, 2, 0. So let's put that down there. 2, 0. Happy or sad parabola? Happy parabola because look, this x when we square it is going to give us x squared, a positive x squared. Our value of a, which sits in front of here, is positive. Okay, so we already know it's a happy parabola. We already know that it goes through that point. So we can draw, like the mustard hit the tomato sauce, our parabola over here. And what's quite handy about that then is that we know that there's a y-intercept over here, and we're not going to bother to try and find other x-intercepts because we already know that it looks like this. So we don't have to go 0 equals, I mean, we could, doesn't, anyway. So let's go. So here we know x. I'm not going to belabor it to find the y-intercept. We know x is 0. So we're going to go f of 0 equals 0 minus 2 squared plus 0 minus 2 squared, 4. So in other words, 0, 4 is a point in our function. 0, 4, there it is. Cool. That one was a little bit more straightforward, actually. But sometimes they can catch us out when it doesn't quite look in the form we thought. Example 6. Oh, I feel like I'm just warming up and we only got 2 more examples. Is this another one of these moments? Okay, so we got h of x equals 1 of x. What type of function do we have? Well, this time we've got a hyperbola. So we're going to do this. Wow, that was a terrible. You'd think that I'd, by now, just had some of these Cartesian planes like insert here. But this is not to scale. Okay, so hyperbolas. Maybe just quickly think to yourself, what are all the things you know about hyperbolas? Okay, the things that come to mind for me are, these are the ones that are like this and like this, or like this and like this. I don't know what that looks like. But, there's in one quadrant, like that quadrant and that quadrant, and something either like that. There were some asymptotes, because we couldn't divide by 0, so like we couldn't have x equals 0 over here. So those are some of the things. Now, with the hyperbola, I think it's worthwhile jot down your asymptotes to start with. So what we know with our hyperbola is that x can't be 0 because we can't divide by 0. So I'm going to draw a dotted line here exactly on this y-axis because that's x equals 0. The other asymptote we've got is here at y equals 0. So I'll just draw that here. Y equals 0 because there's nothing we can, 1 divided by nothing is going to give us 0. So our output's never going to be 0. And then one thing we should know about hyperbolas is that this shape here, because this is a positive a value, it's going to be in the first and in the third quadrants. Because think, if you put a positive number in, let's say h of a positive number, we're going to go 1 over positive number. So our output's going to be positive. So positive, 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 positive is up here in this quadrant over here. Okay. If we put a negative, negative. Okay. So but it's just something that's embedded by now. This quadrant. And maybe it would be useful to put 1 point on our function. So I'm going to choose randomly the input 1. So h of 1 is 1 over 1 equals 1. So the point 1 is on our function. 1, 1. Okay. Cool. And we could have done something here as well. We're not going to go into our lines of symmetry because that's not our focus for hyperbolas at the moment. But just remember that there are these lines of symmetry that go through something like that. Y equals x and y equals minus x. Not the focus for this section, but just a reminder that those are there. Okay, last example. Example 7. F of x equals 6 over x minus 3 minus 1. So for here, what type of function is this? Well, this is also a hyperbola. So here are axes, x and y. Asymptotes, what I said, would be useful to start with. So this is again in this form where we've got x minus p over here and we've got our plus q. So this minus 3 means that we have translated this 3 units right, because p is 3. So it's not a turning point, but it's where those asymptotes are going to meet. And the q is minus 1, so it's moved down by 1. So in this case, we've got an asymptote at x equals 3. Kind of makes sense that if we had 3 minus 3, this whole denominator would be 0, and we can't divide by 0. So x equals 3, over here somewhere, is an asymptote because we can never input the number 3. This whole fraction, the whole fraction can never be 0. Because 6 divided by anything is never going to give us 0. So we're never going to have 0 minus 1. So what we're not going to have is the number minus 1. So q here is telling us our y asymptote because we're never going to have that output. There's no number we can enter into our function to have minus 1 as an output. Okay, so we've got our 2 asymptotes, and what's really useful about that is now we can pretty much draw our function. This value up here is a positive 6. So our a value is positive, which means that the shape is like the one above. That one was in the first and third quadrants. So for this one, we've got it also in this top right. But of course, it's moved right and down. And in this bottom left part here. Let's just maybe take a moment and pause there. Okay, now from this, what's cool is that we have got our intercepts. We've got this one here where we know x value is 0. How do we find the y value? Well, we're going to input 0. F of 0 equals 6 over 0 minus 3 minus 1. 6 over minus 3 minus 2 minus 2 minus 1 minus 3. It's a negative, so it matches at least. And I say that just, imagine, over here you got some answer and y was positive 7. You'd be like, that doesn't match because the positive numbers are up there. Okay, so what we worked out here is that 0 minus 3. And the other piece of the puzzle, the final last little bit is, we do it in here, this x-intercept. We know the y value is 0, so we're going to go 0 equals 6 over x minus 3 minus 1. Now, for this one, instead of solving the whole equation, we know that there's one answer. So this whole fraction has to be 1 over here. So if that needs to be 1, because 1 minus 1 is 0, then 6 divided by something needs to be 1. So what does x need to be? Well, this denominator needs to be 6, so x needs to be 9. But let's solve this algebraically. So we plus 1 on each side equals 6 over x minus 3. Multiply both sides by x minus 3 equals 6. Add 3 to both sides, x equals 9. Okay, long algebraic way of doing it. So x equals 9. What we worked out is that 9, 0 is a point in the graph. Okay, so just to maybe sum up and use this graph as our summing up point. It's been a good year. We need to think, first of all, what type of function are we dealing? Can we recognize that it's a straight line, parabola, hyperbola, soon exponential? Then after that, no logs, not yet. What do we know about it? Has it had a translation? Has it moved up, down, left, right, vertically, horizontally? Are there asymptotes like in the hyperbola? So only functions so far that's had asymptotes. Draw the asymptotes first. It's really useful to draw those asymptotes. So if we've drawn them, like in this case we drew them here, then it was a bit easier to draw our function because we knew kind of where it's at. We're doing the algebra. So like over here I've got the algebra going, but I've got the picture going at the same time. The two are working very much hand in hand. They're not going to conflict. If they do conflict, then warning bells come up. So if we found, in this case, here we got an x-intercept and it came out to be negative from our algebra, something wouldn't fit. Is our picture a little wonky? Is our algebra a bit wonky? So those are the things that we just want to go through and just go through slowly, methodically. And that's why this kind of much longer session now, I mean, it's like half an hour of just going, we basically spent a whole lesson's worth on just drawing functions, reminding ourselves from last year how functions work, so we can just use this function knowledge going forward in the next 7 sessions. So, you know what I say? I say make it maths. Okay, so enjoy all the special people out there.